All right, in 5-0 notes, we need to review factoring and solving quadratics. And the first thing from Algebra 1 that you learned about factoring is you always look for the greatest common factor first. So the greatest common factor in 1, you're looking at 8 and 12. I usually do the numbers and the variables separate. Only one of them has an x, so we can't take that out. But as far as the numbers, 8 and 12, the biggest number that goes into both is 4. So if you take out a 4, remember that factoring is the opposite operation of multiplying. So really you should be thinking this. 4 times what will give you 8x? It would be 2x. And 4 times what would give you 12? It would be plus 3. Now I think you should always go back and look at that real quick and make sure that there's not a common factor in there. There's nothing that goes into 2 and 3 besides 1. If there ever is, it means you took out a common factor, but not the greatest common factor. And as far as what we just asked you to do, that's it for that problem. Okay, you just took out the GCF and there's nothing else to do. In number 2, 10 and 15, they're both divisible by 5. And if I have 2 x's, because x squared really means x times x, and then I have 1x here, the most you could take out of both of those would be 1x. So take out a 5x. This times what will give you 10x squared would be 2x. And this times what would give you negative 15x. So you need to multiply by a negative 3. Notice 2 and 3 inside do not have any common factors anymore. And therefore, you are done. Now guys, you should know if you're wrong or right on these. So don't move on if you know you're wrong. What's the opposite operation of factoring? Multiplying. Redistribute these and actually multiply them out and see if you get the original problem. Okay, so now in the next part, this is going to be factoring and solving. And I will just say, as far as the method, guys, there's like 8, 9, 10 different methods that people have learned, especially if you came from a different school and depending on the year. So I will just say this. If you have a method that you know how to do every single time correctly and you can explain it to me, I will accept your method. Okay, but really make sure you're diligent about this. This is going to be required to be successful next year in Algebra 2, and you're going to need it going forward in this chapter. Okay, so I'm going to teach you in this video some shortcuts. You probably learned factoring by grouping, right? Making everything into 4 terms, which you can watch my other video and look at my other notes for that. So factoring by grouping is fine. That's what you did in Algebra 1 if you're really fast at it. Go for it, okay? But we want you to know some shortcuts. So we're probably going to be working with guess and check and what I call the 90-10 rule, which is the same if you've ever heard of the 80-20 rule, okay, as we call it here at Creek. Okay, but I'm going to call it 90-10 and guess and check, and you will see why. Now, super important for me to point out the difference. There is a super big difference between this direction of factor and the next page directions which say solve. And you can't ask me during a test or a quiz which one it is, so you have to know. Please notice on these solve ones, there's equal signs. You've been doing solving for the past 4 chapters, right? Solve, x equals what? Solve, y equals what? So maybe make yourself a note that in solve, you're going to get answers like x equals something. Versus in factor, notice there are no equal signs. Your answers will be in parentheses, okay? Sets of parentheses. All right, let's do number 3 with our shortcut. So the shortcut is going to be the following. I am asking myself, this is based on what I know about multiplying. And I think maybe we'll actually just go back and do a little side note of that first. Let's do that down here. This is what most of you guys know as distributing. If I ask you to multiply like x plus 1 times x minus 3. Okay, we know that we distribute. I'm going to use a couple different colors to hopefully point out some differences. So typically we do this times this, and then we also do that times the -3. But instead of putting them up here, just so you can see the difference, guys, this is the first term times the first term, which is where F comes from in FOIL. I'm going to put it down here. Those are the outer two terms. That's the O in FOIL. And then I'll use a different color. Then you pick up and distribute the 1 to the X. And I'm going to put it down here for what I'm doing. That's the inner two terms. And then the last times the last. That's the L for FOIL, F-O-I-L. Now that's also called distributing, okay? But the reason I'm separating them this time into the top and the bottom is what I know about multiplying. If multiplying is the opposite of factoring, then really concentrate on this for a minute. So here what we did in green, these give me the x squared, okay, that I would have had together. And then the outer and the inner down here are where you get the x terms. Wouldn't the outer have given you -3x? The inner would give you plus 1x, so we'll just write plus x. And then the last, those two, would be giving you -3. And if you combine like terms, you'd have x squared minus 2x minus 3. Okay? So what are we doing in these notes? We are literally trying to ask you, if we gave you this, what would this part look like? Okay? So notice down here, this is what I'm going to point out. You're going to constantly see me do outer and inner down here together, because these are the terms that give you these two x's that eventually combine to give you your middle term. Okay, so those are really the key. That's what we're focused on. And then we'll always check that those last terms give us that. All right, let's start. It's going to take practice. All right, sorry about that. I got interrupted. Anyway, here we go. On number 3. I know that this is going to be 2 sets of parentheses multiplied by each other. To get x squared, I would have to have 1x times 1x. We don't write the ones. To multiply to get 12, I want to be very systematic and write out all the numbers that multiply to be 12. And I ignore the signs for right now. Okay, so those possibilities are 1 times 12. So always write out starting at 1 and go in order. 2 times 6 and 3 times 4. Now the 90-10 rule says 90% of the time it's going to end up being the numbers that are the closest to each other. So you're going to guess 3 and 4 before you would ever guess 2 and 6. And last resort, you would guess 1 and 12. Okay, so guessing and checking involves this. It means, all right, I'm just going to randomly put 3 here and 4 here. And for me, I don't even think about the signs. I just think about the outer and the inner. If I multiplied these together, they would be 4x. If I multiply these together, they would be 3x. If I combine them to combine like terms, if I added them, I could get 7. If I subtracted those, I could get 1. And I'm always looking here because I know that the numbers add to be the middle and they multiply to be the end. So again, 4 plus 3 is 7. That's not what I want. 4 minus 3 could give me 1. Now I need to see if I can get the signs to work. To get a positive 1, I want this to be a positive 4x and a negative 3x. Okay, so to be positive 4x, I'm going to put plus. To be minus 3x, I'm going to put minus. The only thing left for me to now check is the following. Did I mess up what happens with the last ones? Okay, so -3 times 4 is -12. Check. It works. I am finished. Okay, let's do it again. Number 4. Here's the thing we have to change a little bit. On number 4, I have a 5 in the front. To get 5, that's 1 times 5. All right, to get 2 in the back, that's 1 times 2. Those are my only options. So here we go with our parentheses then. I'm going to say, to get x squared, I know it's x times x, so I'm going to make one of them 5x and one of them 1x. Before you ask, it does not matter if you had written x or 5x. Order doesn't matter, right? If this was like 2, the whole parenthesis, times 3, that's the same as 3 times 2. You just write them in different order. I usually try to stay in the habit of putting the bigger one first, but it's not right around. All right? Combine that with, here's my guess. I'm going to say that 2 is created by doing 2 times 1. Well, let's just randomly guess 1 and 2 there. Okay? The outer, I know the first is 5x squared. I know this is giving me 2, but I have to worry about the signs. I'm worried about the outer giving me 10x and the inner giving me 1x, right? So here's my thinking. 10 plus 1 could give me 11. It's not what I want. 10 minus 1 could give me 9. Again, not what I want. So the checking part of this, guys, is really just distributing and remultiplying these out. The guessing part is just moving these things around. So now, since the 1 and the 2 failed in that spot, you're going to get tired of erasing. Your paper will probably start ripping. So maybe you just mark yourself that this one didn't work. Okay, so maybe you just lightly cross it out or something. It's fine with me. You'd be showing me that you're doing work if you now just go back to, oh, well, now this is 5x. That's the x. But now I'm going to guess the 2 here and the 1 there. And then again, I'm going to check it so that this becomes 5x. This becomes 2x, and I'm asking, 5 plus 2 could give me 7. Nope. 5 minus 2 could give me 3. Ooh, I like that I'm getting the number. Now I need to deal with the signs. If I want it to be negative 3, I need it to be negative 5 plus 2. Negative 5x plus 2x is negative 3x. So to be negative 5, this would be negative. To be positive 2, this would be positive. And now the only thing I need to go back and check is that the 2 times the negative 1 at the end, does it work with this sign right there? 2 times negative 1 is negative 2. So guess what? I did it. That means this is your answer right there. Okay, and I'm going to try to leave all of those lines there just so that you can still see that if you needed it. All right, it's going to take repetition. You have to practice this. All right, here we go. The next one. So the one thing that we now need to write, now that you've seen the process, is always factor out your GCF first. Okay, so I just wanted to teach you the process first. But going back to number 3, literally here's the first thing you should have asked yourself. Is there anything that goes into 1, 1, and 12? And there is not. Nothing besides 1. Okay, so that's why we started. In number 4, is there anything that goes into 5, 3, and 2? Nothing besides 1. Okay, so we were set. I'm going to now start asking you that on every problem. Number 5, is there anything that goes into 3, 24, and 27? And I hope you're saying yes, 3. So you have to factor out that GCF first. 3 times x squared would be 3x squared. 3 times negative 8x would be negative 24x. And 3 times negative 9 would be negative 27. Okay. Now you're just dealing with this guy. Now when you multiply these back together, you have to get the original problem, guys. That means this 3 outside is just along for the ride now. So no matter what you write, the 3 goes in the front. Okay. You're now dealing with, however, you're like dealing with the 3 and this separately. So I'll make it a different color. It's like you're dealing with just a 1x squared minus an 8x and minus a 9. Okay. So for that work, you're going to say, all right, the 3 sitting there. I know to get 1x squared in the front, I'm going to have x and x. And for 9, to get 9, I would get 1 times 9 or 3 times 3. The 90-10 rule says the closer ones are usually it, so you should go with the 3s. And the guessing part is, okay, great, I'll put the 3s in. The checking part is the multiplying it out. Outer will give me 3x, inner will give me 3x. So if I added these, I would get 6x, not what I want. If I subtracted these, I would get 0x. Again, not what I want. So that one doesn't work. Up to you if you're now going to just cross that out or if you are going to erase it. Okay, so we're trying again. There's the 3 that's in the front. Here's my 2 sets of parentheses, x and x. And now switching 3 doesn't do anything. So I'm going to 1 and 9. Again, it doesn't matter the order. Here's what I'm worried about. This gives me 9x. And this gives me just x, 1x. Is 9 plus 1 equal to 8? Nope, I could get 10. But 9 minus 1 could give me 8. Ooh, it's looking promising. Now I need the signs to work. To get a negative 8, I want it to be negative 9x plus 1x. So to get negative 9, I'll put the negative there. To get positive 1x, I'll put the positive there. I have to double check the end. Is positive 1 times negative 9? Negative 9, and it is. And therefore, this is your answer. Okay, because if you multiplied all of those back out, you would have exactly what we started with. Okay, all right, here we go. You can stop it and go a little slower and try practicing some of these yourself. We'll get into some new ones, so do keep going. All right, number 6, is there a GCF? Nothing goes into 12, 16, and 5 except 1. Therefore, we will just go ahead and say 12 is 1 times 12, 2 times 6, and 3 times 4. Do them in order. 5 is 1 times 5. The 90-10 rule says you're smarter to start with 3 and 4. I'm going to say 4x times 3x would give me the 12x squared. And 1 and 5 is all that you've got to deal with. So if you put the 5 there and the 1 there, I'm worried about the outer. 4x and 15x. Those would add to be 19, not what I want. They would subtract to be 11, not what I want. Okay, here's my next guess. So I'll put 4x and 3x, 1 here and 5 there. You gotta try them both. This would be 20x. This would be 3x. 20 plus 3 would be 23, not 16. 20 minus 3 would be 17. Again, it failed. So 5 and 1 are my only possibilities here. So that tells you that 3 and 4 would have failed, right? So the 90-10 rule says once that fails, your best guess is the 2 and the 6. All right, so now you go to 2x and 6x. Again, doesn't matter the order, so I'm purposely putting the smaller one first. And therefore, let's just randomly guess 1 and 5. Outer gives me 10x. Inner gives me 6x. 10 plus 6 is 16. It's looking hopeful. I want negative 16. So I really want these to both be negative because negative 10 and negative 6 is negative 16. To make that negative, I'll put a negative there. To make this negative, I'll put a negative there. I just have to check the last. Does this work? Is negative 1 times negative 5 positive 5? And it is. So we are ready to say that we are good. Right there. Okay. Next one, GCF. 2, 6, and 36 all have a 2 in common. 2 times x squared would be 2x squared. 2 times negative 3x would be negative 6x. And 2 times negative 18 would be negative 36. again, that 2 will just be along for the ride. I'm really dealing with this 1 coefficient in the front. So to get x squared, I know it's going to be x and x. Going on the side and doing my numbers for 18. 1 times 18, 2 times 9, 3 times 6. 90-10 rule says 3 and 6 is the best option. So put 3, put 6. Outer gives me 6x. Inner gives me 3x. 6 plus 3 would be 9. Not what I want. 6 minus 3 is a 3. Looking promising. And again, this does not mean it works. It could still fail. So don't just randomly put something. It has to work with the signs. Okay, if I want -3, then I'm really hoping it's going to be -6 plus 3. So to make this negative, that has to be negative. To make this positive, this has to be positive. And now I just have to check the end. Does +3 times -6 give you -18? And it does. So we are set and ready to say that this right here is my answer. Okay, 8 is a different situation. Remember, terms are split by plus and minus signs, guys. So these were all 3 terms, right? That's why they're called trinomials for 3. There's 1, 2, 3 terms. In number 4, there's 1, 2, 3 terms. Look at number 8, though. There are now 2 terms. When you see 2 terms, I want you to ask yourself, is this something called difference of perfect squares? So first of all, difference right in the name. Difference means subtraction. And subtraction is exactly what we have in this problem right there. Okay, so this is definitely difference. Now I want to ask myself, are these perfect squares? And the square root of 16 is 4. Square root of x squared is x. Square root of 25 is 5. Those are all definitely perfect squares. So in this case, the parentheses turn into the following. The square root of 16 and x squared is 4 and x. So 4x goes in the front of each parenthesis. The square root of 25 is 5, so 5 goes in the back of each parenthesis. And then 1 is always plus and 1's minus, and you're done. But let's convince you that it works. Distribute. There's the 16x squared, right? And here, if I do FOIL, that was the first. Let's do the last. There's the -25. Here's the thing you're not looking at yet, though. Outer and inner is the key, right? Like we've been doing for this whole section. Outer would give me -20x. Inner would give me +20x. When you add those together, you get 0. So notice there's no x term. Again, this is called difference. It only works with subtraction. Okay, so if it was ever a sum of perfect squares, meaning you had a plus sign, it would not be factorable. All right, so this one right here is actually our answer. Okay, well, the technology is not longer working because I can't box that for you, because literally look at what my pen is doing. So anyway, that is the final answer, just not boxed. And I will go ahead and end this video and do the solving part in a separate video. Okay, but I will say to you, the only difference in solving is that you continue on. Okay, so for instance, if I was looking at 6 right here, if this was a solve and there was an equal sign and it said equal 0, you would set each factor equal to 0 and solve them separately. That's what you're going to see next. Okay, so watch the second part.